Sure, whatever you want.
All right, so I'm going to get started. I've got 2 hours of stuff to present in the next hour, so you guys get ready to go. A little introduction about myself, Paul George. As you can see, I've been involved with FIRST for a long time and do a lot for FIRST. I don't know how I get all this done. All right, agenda. Here's the agenda for the pneumatics part. And here's what I hope that you will learn when you're done with this half hour. So, how many people know what pneumatics are? Everybody knows what pneumatics are? So can I skip all the stuff about this part? Yeah. I'll go through it real fast just so we can record on the video, but I'll go through it pretty quick. And then, because I think really the key parts are the latter parts here. That's really, really important for you guys. This stuff you can learn real quick online. Okay, so what's pneumatics? You guys know what that is. And why do we use pneumatics? Why do you use pneumatics?
The right way to apply force in some scenarios.
Correct, but linear, right?
Yeah.
So, I mean, everything is, you know, most pneumatics are linear, or you can get rotary actuators as well, right? But when you're doing linear, it's so much easier than it is with a motor. The other thing is lots of form factors, right? And lots of ways to do mounting. So it has a lot of flexibility to do pneumatics. That's why we use it. You guys know what pneumatics is. So, anybody know what that is? I'm not going to say. So why did I put that in the list? Is that pneumatics?
Yeah.
Uses air to do work, right? That's what pneumatics is. What kind of work is it doing? Making sound, right? It's converting that pressure into sound vibrations. That's work. No different than trying to break up a rock. I'm glad I'm not that guy. Okay, the thing that we worry about when pressure is, how do we describe pressure? 1 psi equals pounds per square inch. That's the thing that's important. The other thing is that we always use gauge pressure for robotic. We don't worry about absolute pressure. On my original training, I had you guys calculate what, if I gave you the gauge pressure, what's the absolute pressure? Anyway. Remember that? And another key thing is your working pressure for your FRC robots based on 2016. So one thing I'm going to say, caveat, right? This is all based on 2016 rules. What's the first thing you do when you get the rules?
Read the rules.
Read the rules, because they change, right? I don't know how many times, I used to do inspections early on in the 90s, I did inspections. I can't remember how many times I had to go to a team and say, I'm sorry, but that is that's no longer legal. Or, okay, that is a very hard discussion to have with a poor team, especially when it affects their whole robot. So you've got to read the rules, because they do change. All right, airflow is also important. And what restricts airflow, that's the thing you got to pay attention to. Orifice size. And anybody know last year what the maximum orifice size was for tubing and for valves? Anybody remember? Does anybody know? Okay, well, I'll talk about that later. Tubing length. Why is that important? Because, speak up.
Because you got to pressurize the whole thing.
You got to pressurize the whole thing, and what else happens?
And if you can't get
You
leak.
get losses, right? As the air flows, you get losses down that tubing. So if you want something to operate as fast as possible, what do? Keep your tubing as short as possible. And then the other thing that can affect your airflow is available air supply, right? So if you don't have an infinite amount of air available, it's going to slow down how fast you can pressurize that cylinder. So you got to make sure you have lots of volume to it. All right. And the way that we quantify airflow is with CFM, cubic feet per minute. Oh no, there's the equation that I never use. And you also talk about a thing called standard cubic feet per minute. It's a big thing in industry. One thing that I learned after I got in it, when I started doing this presentation, was There's not one standard for standard cubic feet per minute. I didn't know that. Everybody has their own standard, so make sure you ask what standard you're using if you're gonna use standard cubic feet per minute. Okay, so let's talk about component. Everybody know, should I skip all the component stuff? You tell me what this is. What is this?
Air cylinder.
Okay. What's this?
Bigger cylinder.
Wrong!
Could've been.
That's a tank.
I've seen a metal tank.
What's this?
Regulator.
Regulator, right?
Yeah.
What's this?
Solenoid.
Solenoid valve, all right? So, what kind of solenoid valve?
Internally piloted.
It is internally piloted, but what do you see on this solenoid valve?
Some red button.
See, I mean, it's a 2 ports, right? But how many actuators do I have?
One's like one.
One. So what is the other actuator that you're not seeing? Spring return, right?
Yeah.
Okay, so on a spring return actuator, what happens when I disconnect power on this actuator?
It goes to a default. It goes to whatever it brings back.
It goes back to its de-energized state, right?
Yeah.
So what happens on your robot when at the end of the match and you get the disable from the FMS? What happens? What happens on your robo-reel?
All solenoids return back to that.
Well,
Yeah.
more generic than that. What happens when
All
you...
outputs are disabled.
All outputs are disabled, right? So what that means is this solenoid valve is what? It's going to de-energize. That means you could get movement after the match is over, right? Now, I'm not suggesting you do that. Because it could be a good thing or it could be a bad thing, right? Alternatively, if I have 2 solenoid valves, right? If I'm trying to hold my robot up, like last year, I'm trying to hold my robot, right? And now on a dual solenoid valve, dual solenoid valve, if I de-energize both of them, what happens to the solenoid valve? It stays where it's at, right? So now if I have a pin, and this is what 1038 did last year, is they used the motor to pull the robot up, but then they had a cylinder that went inside the lifting mechanism, and right before the end of the match, it would lock, it would extend, and it didn't matter what the solenoid valve did, it would hold the robot, okay? Because the air pressure does go away, right? Does the air pressure go away when you de-energize the robot? No. So that's something that's very useful. Okay, you know what this is? Tubing.
Pressure gauge.
Okay. What's this?
Dump valve.
Dump valve. It's really just an on-off valve, so it depends on how you're using it, right? Whether or not it's a dump valve or something else. Fitting, teeth, fitting. Oh, you know what I didn't bring? I didn't bring a pressure relief valve. What's this?
Pressure switch.
Pressure switch, right? Okay. How many people know what this is? It's hard to see.
Flow control.
Flow control. So why do I need flow control? What do I use it for?
To change the speed of whatever change the speed of your cylinder, whether in or out.
Okay, so here I have a cylinder, right? What limits the speed of the cylinder?
The output air pressure. Airflow.
The bore.
Airflow going in, so the faster I can put air in there, right?
Airflow out.
And the airflow out, right? So the problem is typically the cylinders will go bang, right? Bang, bang. You ever hear the term bang, bang? That's where that came from cylinders. Bang, bang. They go bang or they go bang. Bang, 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 bang. And I'll tell you the story. Again, when I was still doing, this was at Championship, okay? It was actually when we were still at Epcot. I was inspecting a team, and I was looking at their pneumatics, and I said, "What's that?" They had a tubing coming in, a little block, and then a little screw, like that. I said, "What's that?" He says, "Oh, that helps keep the speed of our cylinder from going too fast." I said, "Oh, where did you get that from?" We made it. Wrong answer. And actually back, it was in the early days, and flow controls actually were not legal.
Oh.
Yeah, oh. So you had to use some other method to keep your robot from beating itself to death when you extended and retracted cylinder. And they were beside themselves. Now, they already had competed, right? Because they were been to a regional, now they're a championship, and I'm telling them, they have illegal pneumatics parts on their robot. They were not very happy. I wasn't very happy either, but I had to tell them that they had to take them off if they wanted to pass inspection. I don't know ultimately what happened, because I did the initial inspection, and then and I turned in the report afterwards, and I was also one of the head referees, so after the first, I think it was on Wednesday or Thursday, I couldn't do inspections anymore, I had to go and do the referee stuff. So I don't know what actually that they did, but anyways, the lesson is, do not make pneumatics components and put them on your robot, because those are definitely illegal, unless they are like vacuum components, right? You can do vacuum components. So, okay. Now, when you want to control the speed of a cylinder, you put the speed control on the inlet. So if I'm trying to control the speed of the cylinder going this direction, do I put it on the exhaust or the pressure side of the piston? Does anybody know?
Depends. It's meter in.
I would say
meter
exhaust.
out.
Exhaust. You say depends.
Yeah. If it's a meter in, you put it on the input. If it's meter out, you put it on the input.
So why would you meter in?
Just a choice you make, I think.
So the conventional wisdom is that you meter out, you meter the exhaust.
They do
And
make
the-
meter in valves.
They do make meter in valves. There's nothing structurally with preventing you from putting or buying a flow control valve that meters on the in instead of the out. But the conventional wisdom is that you want no restrictions for the air going in when you're applying force. So my personal opinion is to always meter out, because if you meter in, you reduce slightly the amount of force that the cylinder can apply. So I always meter out.
Also, if you're lifting any kind of weight, which if you, as soon as you open and switch the valve, if you have any kind of weight and you're not restricting the outflow, it can instantly drop.
Correct, that's right. I didn't think about that. So if your cylinder is like this, right, and you're holding up a heavy load, right, and now you exhaust it, then the
You're restricting
load,
the airflow in, but not the airflow out.
you're
The load will
basically
instantly
creating a
drop.
vacuum on the backside, and this thing will just fall. There's nothing to prevent it from fall if you just open this up to air, other than the restrictions in your tubing. So that's a good point, thank you. Okay. All right, so that's all the components. Let's see if I covered everything in my presentation. Again, be conscious of the 125 PSI, pressure on your compressors. And oh, by the way, for those of you that haven't been around as long, this is the original compressor you had to use on your robot. That one weighs about, what, a pound? Maybe half a pound, well, a pound and a half?
Just a little less than a pound.
This one weighs like 5 pounds or something like that. Cylinders, we talked about that. Solenoid valves, electric versus spring. Shut-off valve, regulators. Now, one thing we didn't talk about was, because I didn't bring one, I forgot, was a pressure relief valve or rupture disc. This is the drawing for a rupture disc. A pressure relief valve is self-resetting, right? Once the pressure goes below, it will reset and your system can continue to function, right? Because you still have air in your system. What happens on a rupture disc? You might know. Once it blows, you have your open atmosphere, your system doesn't work anymore, okay? So if it was me, I would never even consider one of these. I would always use the pressure relief valve. So. Pressure switch, gauge, fittings and tubings. One thing I would be very careful about is so if you can tell, we like to use these quick release fittings, okay? And they work great when the tubing is sized properly for the fitting, okay? If not, you will get air leaks all the time. The other thing too is, cut the end of this dead square, all right? If it's cut at a bias, and you push it in there, it's gonna leak, all right? So just be aware of that. And sometimes you get millimeter spec tubing. You have to use them with millimeter spec fittings. If you don't, they're gonna leak, okay? They may fit, but they'll still leak. And believe me, you do not wanna chase air leaks. They're a pain.
Soapy water.
Soapy water, that's correct. Okay, receiver tanks, that's what this is, and, anybody want to comment about that tank right there? Come on, Ted, you know the answer? You chuckled, you know.
Yeah, I do.
That tank is illegal. You cannot use the clippered white tanks, because they, have a tendency to explode. The clippered black tanks are legal, clippered white tanks are not. We have some of these back in the shop that we don't use. You can still use steel. Now, you notice, nice thing is plastic, they can be up to 500 ml in volume. Steel can be up to 16 cubic inches, right? So the steel ones you can get actually larger, but they're heavier. So there's a trade-off there. Most people use the plastic ones nowadays. No, hardly anybody uses the steel ones. Okay, and then flow controls. And the way the flow control works, for those that don't know, it has a check valve. So as he was describing metering in versus metering out, it means that this check valve is in the opposite direction. Okay, so it's not like I can take the flow control and put on the other port. It doesn't work. It just means that it's controlling flow in the reverse stroke, the other stroke. You have to get in one with this check valve in the opposite direction, because when you're basically, when you get pressurizing that side, it goes through the check valve and bypasses the needle valve. So when you're metering, it's actually, this check valve is closed, and this is the only path for the air to escape. Any questions about that? Simple concept that you can get it wrong if you don't know what you're doing and not understand why it's not working. In my other training, I made a big deal about all the ANSI symbols, because I really encourage people to make drawings of their pneumatic systems, especially if you have more than one or two cylinders, because it can, I don't know anybody else, but I don't care how good you are, it seems like it turns into this spaghetti of fittings, or tubing and wiring, and you can't remember which one went to which one. You know, is this one, and label the tubing, you know. So you had a problem with the robot, right? You disconnected the tubing. If they're not labeled, which one goes on the which end, right? If you have a drawing and you have everything labeled, then you know.
So one of the things you can do, like what we do, is use different colors
Yeah,
for the flow direction of the air.
okay,
So if you do remove the blue one, for example, it only goes on that one spot.
right. So so what he's suggesting is, if I use blue on this side and orange on this side, and what I would do is I would put blue tape and orange tape. That way you always know the orange one goes there, the blue one goes there. That's another way to do it.
It's also easier to chase your lines back to.
And it's easier to chase them.
We had a lot of tubing for first choice.
Yeah.
'Cause that's all we could do.
We got like 6 colors, but that makes it easy.
And don't forget, sometimes, you know, they make this tubing that is pre-coiled, right? So that it will stretch and compress. That can be very useful, you know, especially like on end effectors, on the end arms that extend out, to manage these instead of you trying to manage it. Because this has tendency to take a shape, wants to be curved, right? So it goes where you don't want it to go. Okay, encourage you definitely, if you want to get all of the ANSI symbols for drawing your pneumatic drawings, and here's a couple places you can go and get those, download them. Just do a Google search. All right, so who wants to tell me, we're going to do this pneumatic circuit real quick. What is that?
Compressor.
Compressor, that's your compressor. I'm starting at the beginning. That's the compressor. What's next?
Rupture disc.
Rupture disc, correct.
Questionable choice.
Don't ever use those.
Don't ever use those, but that's a rupture disc. That's good. Gauge, pressure gauge, okay.
Pressure switch.
Yeah. What's that?
Dump valve.
That's your dump valve, correct? What's this? Pressure regulator, okay. So what have I just described? What is this right here? Anybody know? That's your air supply.
The high pressure side?
That's the high, well, yeah, this is the
Up to
high
there.
pressure side over here, right? This is your low pressure this is your working pressure to the rest of your robot, right? This is what? The minimum circuit first requires on your robot. So if you put pneumatics on your robot, you must have all these components, okay? So that's one of the disadvantages of pneumatics. If I just want to put this cylinder on, right, it means I have to add all of this stuff.
You don't have to have a compressor, do you?
You don't always have to have the compressor on board, and I'll talk about that in a few minutes. Okay, so next, so that's what that circle represents. Here's my solenoid valve, and here's my cylinder, right? Would you add anything else?
A tank,
The tank, why would you add a tank?
so your compressor isn't constantly running and you have a solid working pressure,
Correct. And why is that important?
because
Don't drain the battery, right? That compressor, even, I mean, this is a big one, but the little one that they've got makes a difference on how much it pulls down the battery. And in our robots, in previous years, we've seen a difference in the speed of the robot when the compressor's running and when it's not,
Oh, yeah.
yeah.
right?
It's like shifting gears.
So you need a low gear, just turn on the compressor. So where would you put, where would you put the air receiver?
The last thing on the high pressure side before you get to the regulator.
So right here?
Yeah,
Okay. Actually put it right there, but that's okay, close enough.
it's the same thing.
It's the same thing, it's all on the high pressure side. Why do I want to do on the high pressure side? Why do I-
Store more in the same amount of volume.
Correct, I can store more air volume to the same, because it's 120 PSI, 125 PSI instead of 60.
Yep.
All right, any questions about this? You guys are too good. Okay, cylinder sizing. Force equals pressure times the area. It's a simple equation. From that, you calculate the bore size, and then, which gives you the internal diameter of your cylinder, which is also the size of the piston. And then you specify these items. Anything missing? Do you think anything's missing? We already talked about it a little bit. Where do I specify how fast the cylinder is? You don't. It goes as fast as it goes. There's no specifying, there's not a low-speed cylinder and a high-speed cylinder, like there's high RPM motors, the high torque, low torque, none of that stuff. It's just gonna go based on your system, that's how fast it'll go. So you don't specify the speed. All right, quick example, you're gonna lift a 160-pound robot 5 inches off the ground. How big's the cylinder? Quick, do the math. What are you guys waiting on? All right, never mind. What's the stroke? I picked 6 inches. Why did I pick 6 inches? Because if I'm going to raise it 5 inches, I can't have the cylinder dragging on the ground, right? So I have to have a 6-inch stroke. That way my cylinder is 1 inch off the floor. All right. So I'm going to calculate the bore. And what do I calculate first? Come on, quick. We already went through this.
Force is pressure times area.
Correct. So you calculate the area of the piston, right?
We gotta go.
And from the area of the piston, oh, I should have backed up. We usually, FRC robots have 60 PSI max on the working side, right? Is it always 60 PSI? When you're drawing air, it's not gonna be 60 PSI. So when I do the calculations, I always use 50 as a conservative number. All right. So the area turns out to be 160 divided by 50, 3.2 square inches. Next step, calculate the diameter based on that. 2.02 inches. Anybody here specified a 2.02 inch cylinder before? Can you buy a 2.02 inch cylinder? No. No. Well, yeah, you probably can, if you get one custom made, you can get a custom made one, but why would you want to? So pick a 2-inch bore. So, and part of what allows you to do that is I'm conserving on my air pressure, so if my pressure's just a little bit up, plus it's real close to that, it's not, you're not gonna see any difference. So, anybody, any questions about that? So sizing a cylinder is pretty straightforward. Now, that calculation is based on what? Push. The push, right?
Pull area.
Right, so when I'm pushing this direction, I'm using the full diameter of the ID of the piston. On this side, what gets in the way?
Rod.
The rod. So when I'm pushing back, I have proportionally less force. So just be aware of that. If this is the direction that's important, then you have to redo your calculation. So what you would do is you would pick a 2-inch diameter cylinder, 2-inch bore, go pick rod size, and redo the calculation, and you'll probably have to go up the size on your cylinder, okay? So it's an iterative, sometimes an iterative process. So watch out, side force. What is side force? What's side force? Yep, go ahead.
Force perpendicular to the piston rod.
Right, so it would be this way, pushing this way, right? So, what's that?
I just said, no.
Oh. So, if you do that, what can happen?
You bend your rod and your piston's not gonna work anymore.
That's one thing. What else can happen?
Blow the seal.
You can blow out the seal. So, watch out for that. I have, you can buy cylinders in stainless, but let's say I need a stroke that's only that long, right? What do? I put a hard stop to get the cylinder to stop at that point. It doesn't care. It just stops. Can you talk about that? So, there's not much of a dial on that speed control. So if you're trying to do that repeatedly, exactly, it's very difficult. Plus, as the air pressure changes or the temperature of the air changes, then it's also going to influence how fast it exhausts the air. So you can't, it's very, very difficult to get an accurate speed setting. They do make dials, by the way, with numbers on them, so you can at least do that. And then friction in your mechanical system could be a problem. So a lot of times people very much underestimate how much friction they have. And also, all these calculations are based on this being perpendicular, orthogonal to the force or the object that I'm pushing, right? So if I'm pushing in an angle, what's that do? It reduces the amount of force that I'm actually applying. So in flying saunders here, the Frisbee here, I forget the name of the game. We use the cylinder, forget the name of the game.
Aerial assist.
Aerial assist, right? Or no,
Ultimate ascent.
Ultimate ascent. Ultimate ascent. We had our Frisbee shooter had to go up and down. We use a cylinder. And so you have to be very careful because when you're doing the calculations, right? Because as you start out this way, it's perpendicular, but as this moves up, what happens? This thing is, I forget which way I'm doing. The angle is changing. So we had to increase the size of the piston by 50% because of that angle. Also, more than 2 positions, right? Cylinder likes 2 things, all the way in, all the way out. If I want to stop halfway, in addition to all the way in and all the way out, how are you going to do that? You can do mechanical stops. What else could you do? Multi-position cylinders, or it could have 2 cylinders, right?
Yeah.
So one doing one position. Okay.
Center
So they
closed
could be
valve.
additive. What?
Center closed valve.
A center closed valve, right. But that's all based on timing. Not easy to do.
No.
It's not easy to do. So what he's talking about is on your solenoid valve, okay, it has, instead of just 2 positions, which I showed on there, which was either this way or this way, it actually has 1, 2, 3. And in the center position, everything is closed, right? So what you're doing is you tell the cylinder to move, and when it gets to the spot that you want, you tell the cylinder to go to the center position and block all the exhaust air and the air coming in. And theoretically, your load doesn't carry the cylinder down, right? But it's also very much a timing thing, right? So it's not recommended. Other thing to watch out for, large air consumption. So we talk about that. If long delivery time, so if you special order cylinders, they can be much longer than 6 weeks. So you always want to look for cylinders that are stock. 2016 requirements. Again, we talked about the what components can go on the high pressure side. You have to hard pipe. So if you look on my compressor here, on this particular compressor, the nice thing about it, it actually had two pressure ports. So our pressure relief valve is actually on one of those ports. So it's hard piped, so that's perfectly legal. You cannot use this tubing between your compressor and your pressure relief valve, okay?
Are there any recommendations for the casting on the new compressor? I've seen many teams that have had a long pipe sticking out, and you can actually just break the entire casting with the threads right off.
My recommendation is put your pressure relief valve, so put a T in, right, a very short, so this is called a nipple. Put a very short nipple, put your pressure relief valve in, and then put tubing from there on. So minimize the amount of hard piping that you've got. And then, if you're really anxious about it, then physically mount that to the, tie that into the compressor so it can't move, right? So mechanically link them together. That's what I would do. Typically, this is what we typically do. So we have our, missing the nipple going into the compressor. We'd have our pressure relief valve, we have our pressure switch, and then we do tubing from there on. That's just what we typically do. And sometimes we actually use what they call a cross. So this is a T, use a cross, and then we put our, we would have our gauge on one side, pressure switch on the other side. But, big thing, your pressure switch so the Robo-Rio has to control the compressor. You can use the spike or the PCM. That's the pneumatics control module. And the pressure switch has to be connected to the PCM or the Robo-Rio. This trips out a lot of teams, especially rookie teams. They think that what they can do is put the pressure switch in line with their spike, control their spike, and that's not allowed. Yeah.
Is there any real reason not just use the PCM?
I don't know. I haven't used the PCM last year. We just used the spike and the pressure switch. And I don't know why, because the controls guy did it, but it's nice, compact, and
It does all that stuff.
it does all that stuff for you, so I don't know why you wouldn't. Because it connects via CANbus, right? So you control the
You
CANbus.
got to turn the compressor on and off if you're using a spike, don't you?
Yeah, if you're using a spike, you have to
It's
write
all
that code.
manual, yeah.
Yeah, it's in that, you have to write the code
Yeah.
inside your Robo-Rio, where the PCM kind of embeds all that
That's
stuff
for you.
in there. You just tell it, enable, basically. With the PCM, you just tell air pressure enable, and it takes
Tell
care of
that.
all that. Yeah.
You don't tell that. When the robot comes on,
Oh, okay,
it just does it.
okay. Let's see. Oops, back up. Real quick. Outputs from modal valves must not be plumbed together. You understand that
Oh,
statement?
increase the airflow, try to parallel.
So what they're saying is, let's say I have a large, so let's say this is my cylinder, and here's my solenoid valve, and I'm not getting enough air to get this thing to operate as fast as I want. So what teams will try to do is they take two of these, put them back to back, and then outside here, they tee them together, and then go into one cylinder.
Yeah.
That's totally illegal, okay? And that's for safety reasons. Let's see. So you can do it with motors though, you can parallel outputs from motors, but you can't do it in the pneumatics. I don't, sometimes, all right. Solenoid valves, last year was 1/8" port diameter. If you guys remember from my presentation, we had this big discussion about CV ratings, right? That used to be how they would qualify solenoid valves, is by the CV rating. That's basically a measure of how much flow you can get through the ports. They got rid of that, and now they made it simple and just says maximum 1/8". I think these are 3/8, so, or 1/4 inch, sorry. Okay. Required components. We talked about this already. So that's what it looks like. And so basically, you were asking that question, so you can see they've minimized the amount of hard piping coming out of the compressor. And then after that, even though this is all high pressure side, they did it with tubing, okay? You don't have to do the whole high pressure side in brass tubing. Only this connection from the pressure relief valve to the compressor. So this minimizes the lever arm that you've got, right? If you got this thing stuck out way out here, you can apply just a little bit of force and get a whole lot of pressure, right, to break it off. So this compressor only has one port. Okay, and so that's pretty straightforward. Now, compressor off board. This is last year's robot, our off-board compressor. And this was option 1 last year. And that's basically what we did. We have the compressor off board. They show actually a bleed valve right there. We actually put our bleed valve down here. I don't know why they put it there. This acts as both, right? So when you're pressurizing, this is open, and then when you remove this piece of tubing, this now becomes your bleed valve to relieve all the pressure. You don't have to put these tanks in series like this. I don't really know which is better, putting them in series or putting them in parallel. Personally, I would put them in parallel, but I don't know. So that's one option. So what this means is you have 2 connections to your robot. One for the pneumatic connection and one for the motor, right? And that's what we have here. We use one of these little mini Andersons, and there was a corresponding one on the robot that's connected to the spike, or the PCM, whichever one you want to use. This is option 2, and in this case, they put the pressure gauge here. But what that means is now I've got 3 connections, pneumatic and 2 electrical connections. I don't know why you would want to do that, but they give you that as an option. Any questions about that? Clear as mud? What's the limit on the number of air tanks that you can have? Is there a limit? There wasn't a limit last year. There's not a rule against it. However,
Read the rules.
no, read the rules. You can put 100 tanks on your robot.
Wait.
What's the problem?
Wait.
Weight could be a problem, but that's not the problem we're getting at. This is
It'll take forever.
You'll never get it pressurized. You cannot use an external, you cannot like bring your DeWalt, air compressor and plug it in and charge all those tanks.
Coffee
Right?
was doing that at Queen City.
Correct. It was a big problem when teams had all kinds of tanks. There was one team, I don't remember what event it was, it took them 17 minutes to charge all their tanks with that compressor. And that was a problem because they were in the finals. Okay, you do not get 17 minutes between matches. They had a problem. They had a big problem.
Was that States 2013?
I don't remember. That could have been 2013. So there's not a rule against it. There's a practical limit, okay, about how many air tanks that you can have.
And you can always use 2.
Okay. So the next question is, how many air tanks should I have? It's a hard problem, basically. And what you're trying to do is limit, as Ted was talking about earlier, limiting how often the compressor runs. And it all depends on how many actuators, how many times they cycle, how big they are, all that good stuff. There are equations you can use. Here's this nice rule of thumb. It wasn't designed for robots, it was designed for industrial compressors, where you size the air receiver or the air tank in gallons based on the compressor capacity. In the case of this compressor or the other compressor, it would, at 500 ml, I don't know if I have that on here or not. Yeah. So, based on the rule of thumb, you would need 8 plastic tanks, based on that rule of thumb. Okay?
That's a lot.
That's a lot. So, my best advice for this is test it. Make a good educated guess on what you think you need, based on the size of your cylinders and how often you're in a cycle, and then test it. Because you're not going to know for sure until you test it. Okay, any other questions? I ran over on this one.